In example 14 of chain rule, it asks to write the equations of each vertical and horizontal tangent to the graph given. Recall that the slope of the tangent line comes from the derivative of the function. All right, so the first step is to go ahead and find the derivative, and then we'll talk about how to find vertical and horizontal tangents. All right, so notice that we have a composition of functions here on this function. So if I want to find the derivative of this function, we're going to have to use chain rule. So the first thing I'm going to do is I'm going to rewrite this as a power, so x squared minus 4 to the power of 1/3, and then we'll take the derivative. All right, so our outer function is the 1/3 power, so we're going to bring the 1/3 down. Remember, keep the inside function the same. Subtract 1 from my power. 1/3 minus 3/3 is -2/3. And then by chain rule, you have to multiply by the derivative of that inside function, which would be 2x. All right, now again, if I was just looking for the derivative on a free response, you could leave it like this. However, I'm going to be using this derivative to find some information. So I'm going to rewrite him as a simplified form. So the 2x is going to be in the top, and in the bottom we would have 3 times x squared minus 4 to the positive 2/3 power. Okay, so again, why we need to take the derivative is we were asked to find equations of tangent lines. So we need to find the derivative to find those slopes. All right, so now what tangent lines are we asked to find? We're asked to find vertical and horizontal tangent lines. We've talked about horizontal tangent lines before in Unit 2. So think a horizontal tangent line or a horizontal line is a flat line. So the slope is going to be 0. So what you want is you want y prime to equal 0. Now notice that y prime, remember y prime represents the slope, is a quotient. Here's what we got for y prime. So when you have a quotient and you want to set a quotient equal to 0, really what you want is you want the numerator of your derivative function to be equal to 0. And that's where you would have a horizontal tangent, because 0 divided by anything is going to be 0, except, of course, 0. 0 divided by 0, remember, is undefined. Now, if I was asked to find, actually 0 over 0, sorry, is not undefined. 0 over 0 is indeterminate. Now, if I wanted to find a vertical tangent line, that is an undefined slope, right? From Algebra 1, think of a straight up and down line. It has undefined slope. So you can still find equations of vertical lines, just x equals a number, but you want the derivative to be undefined. In other words, you want the denominator to be equal to 0. So we want the denominator of y prime to equal 0. Okay, so let's first start with vertical tangent. All right, so if I want to find a vertical tangent, as I just said, we want the denominator of our derivative function to equal 0. So notice our denominator is 3 times this x squared minus 4 to the 2/3 power. Well, that's technically going to be 0 when just that x squared minus 4 equals 0, right? The 3 doesn't change anything, and the power isn't going to change anything if you're taking 0 to that power. So when is that true? Well, that's when x is equal to positive and -2. So you would have a vertical tangent at x at -2 and +2. Now, if I'm writing the equation of a vertical line, recall it's just x equals a number. So guess what? We're done. Those are the equations of those two vertical lines. Now, if I want to find a horizontal tangent, what we're going to do is we want to set the numerator of our derivative equal to 0. So our numerator is just simply 2x. So when does 2x equal 0? Well, when x equals 0. Now, that's not the equation, though, because we're looking for a horizontal tangent line. Remember, the equation of a horizontal line is y equals a number. So this gives you the x location, and you've got to find the corresponding y. Now, where do I plug this in? Not into the derivative. To find the actual value of the point, we're plugging it back into the original equation. So to find the y value when x is 0, when you have a horizontal tangent line, you're plugging in 0 into that function. So you would end up getting the cubed root of -4, which I know looks weird, but that's okay because you can take an odd index of a negative number. But you might take that negative out. The cube root of a negative will be negative, so we might rewrite this as negative cube root of 4, and that's as simplified as you could make it. So the equation of the horizontal tangent line is just y equals that y value as where x is 0. All right, so that's how you would find the equations of vertical and horizontal tangent lines. Number 15 is our last example for chain rule. And again, I'm back to the class recording. And in the class recording, it is number 4. So when I talk about the graphical example, that's what we're doing here, which is number 15 in your notes.
Do the graphical one. So the graphical one is very similar to what we just did with the numerical one, and we've done graphical problems before. So if I'm finding a derivative, what am I looking for on a graph if I'm looking for a derivative?
Slope.
Slope, exactly. So when you hit a derivative of a number, then what you're looking for off of that graph is the slope. Okay, so we've got the same setup here. We've got h is f of g of x, and then we also have the flip of that, r, which is g of f of x. Okay, so we want to find h prime of 3 and r prime of 9. So the first thing we'll do is we'll do h prime of 3. So before you can find h prime of 3, you got to find h prime of x. And that's exactly what the same thing as number 2 was. It's going to be f prime of g times g prime, using our chain rule. So now h prime of 3, everywhere you see an x, replace it with 3. All right. In the numerical one, we just look for where is g prime of 3. In the graphical one, we have to know how to read a graph. So I'm going to first find g of 3. So g of 3 is just the value of g at 3. Now it's kind of confusing. F is the blue graph on here and g is the red graph. So this one is g. I know that's a little confusing. So that one's g. Okay, so I want to find g of 3. So that would be right here, right? So when I'm looking for g of 3, I'm looking for the y value of g at 3, which, does everybody see, that would be 5. Everybody good with that? Any questions? Okay. Times g prime of 3. This is the slope of g at 3. Okay, so the slope of g at 3, can somebody tell me what the slope at 3 would be?
1.
1. Okay, so now I have to multiply 1 times f prime of 3. So now I need to, or sorry, f prime of 5. So now I need to go to f at 5, which would be right here, and f prime, so f prime, that's the slope of f at 5. Somebody different, tell me what that slope is.
1/2.
1/2. So we have 1/2 times 1. So our final answer is just 1/2. Go ahead and do now r prime of 9. So r is a different function. We switch which one's the inner function and which one's the outer function. So go ahead and do that by yourself. I'll give you about a minute. And if you didn't get it and you can't see why, please let me know. Okay, we all good with -2? Okay. The last question I want to ask you, which is pertaining to this graph, what if I asked you, looking at this graph, what is, so remember this blue graph you see is f. What is f prime of 6?
It doesn't exist.
It doesn't exist. Right, it's undefined because
The slope from the right and the left aren't the same.
Correct. Everybody see that? So f prime of 6, the slope from the left, the slope from the right, don't agree. There's a cusp there. Okay, so if you're doing a graphical problem, and in that problem, you know, like here I had to say f prime of 9. If that was f prime of 6, then that would be undefined. And so you would say undefined or does not exist because of that cusp. All right, so that might sometimes happen with those graphical problems where you have those cusps happening. Okay.
Ms. Freeman,
Yes.
does it have anything to do with differentiability? Because since it's like a sharp point, then it's not differentiable, so therefore it doesn't have a derivative.
Exactly. Yep. Exactly. Those are not differentiable. So everywhere those graphs of f and g have those points, they are not differentiable there. So the derivative does not exist. Well done. Okay.